Good morning, students. Am I audible?
Yes, sir.
Yes, sir.
Okay. In our previous class, what we have discussed, can anyone brief on that? We had studied one more type of control statement. Which one was that? Nainashri, can you recall what we have studied in our previous class?
So actually, I've been disconnected from the class. So
Anyone else? Nikhil?
If else, sir.
If else. Yes, Omkar. Yeah, you can go ahead. If else, what we have studied in if else?
So there are two blocks in that. One is true block and another is false block. So if the condition is executed, we need to go to certain statements, and if the condition is false, it will go to false block.
Okay.
And if it is true, then it will go to true block.
Yes.
Yes, sir. That's what I know.
Yes. So we had studied a type of a branching statement called as a if else. It is also called as two-way branching. Why two-way? Because there can be two different possibilities it can travel through. The flow of execution can go through it. Okay, when the condition is true, Priyadarshan, you want to speak something? Okay. So whenever the condition is true, then it will go into the block called as a true block, and the statements inside the true block will be executed. Okay, and obviously the else block will be skipped during that time. Second possibility is that when the condition becomes false, during that time, the else block statement, that usually we call it to be a false block statement. So all the statements under that particular else block will be executed. Okay, either of the one block will be executed, and we need to remember that at any instant of a time, both the blocks will never get executed. Either true block gets executed or false block gets executed, depending upon the result of the condition, right? Okay. Now, in today's class, we'll just go through the different programs in order to understand the if else in a better way. Let me share the screen. Okay. Okay. So let us write a program. Okay. The program, what it should do is that accept two integers, okay, and display whether let me I'll make a little change here. Write a C program to read two sides of a geometrical shape. Okay, geometrical shape. Okay, then and display whether the shape is rectangle or square. Rectangle or square. Do you recall this particular problem, students. I had given this problem as an algorithm, one of the algorithm as a homework. Do you remember this?
Yes, sir.
Right?
Yes, sir.
Okay. Yeah,
Yes,
we had
sir.
also discussed on this one. Okay. Now, let us try to write a program for this square rectangle dot C. Now, so I think now the problem statement is very much clear for you. Now here, what it says, C program we need to write wherein it should read two sides, okay, of a given geometrical shape. So we are going to enter two numbers. Based upon those two numbers, the program should display whether the geometrical shape is a rectangle or a square. Then how can we compute, how can we come to know whether the geometrical shape, when we enter two sides, values for the two sides, then how can we find out whether that particular geometrical shape is a rectangle or a square? Okay, now,
Sir,
yes. Yeah, go ahead.
sir, if both are equal, then it is square, and if they are not, then it is a rectangle.
Yes, very good. So if the entered
But in rectangle, opposite
the
sides are equal,
values
sir.
are, yes, if the values are same, then we can say that that particular shape is a square. If they are not equal, then we can say that it is not a square. Definitely it could be a rectangle, right? So let us declare some variables here. Say int s1 side 1 and s2 as side 2. Okay, then we will ask user to enter those two sides. So printf, okay, within the double quote, enter two sides, semicolon, then scanf. Since I want to read two values, so continuously I will write %d, okay, %d and %d, double quote complete, comma, and then what? I need to store it into the two variables. So I have to use the ampersand symbol and then S1,
S1 and S.
ampersand symbol S2. Okay, I hope this is clear now. Next, what I should do now? I need to compare the values, isn't it? Now the input part is done. Declaring the variables and initializing the variables are done. Input part is completed. Second step is in the flow is the calculation or the computation here. The processing we need to do. Now I need to find out whether that shape is a square or not. How can I write the statement here? What statement I should? If within
S1 is
If
equal to
bracket
S1.
S1 equals to S2, right?
Yes, sir.
Okay, then, so within the bracket, I'm going to write the statement over here, right? So if
Yes.
S1 is equals to S2, then the shape is what? It is a square. So I will just
Square.
message printf, it's a square / complete. Then suppose if this condition is false, then that has to be handled in another block called as a else block. So else, and here I will write a pair of brackets, and within that I will write another statement saying to be printf, it's a rectangle. It's a rectangle. /n, double quote complete the double bracket, close the bracket, and then semicolon. Okay, now, so do you understood this one, what we have written the program, and is that correct? Are there any mistakes? Can anyone try to check it? We have the input statement wherein we read the values, two variables. Okay, then compare S1 is equals to S2. If that is true, then it is a square will be displayed. Then if those two are different values, then it's a rectangle. So rectangle will be displayed. Is that all correct? Is that correct, students?
Yes, sir.
Okay. Anybody finds any mistakes there? Anybody finds any mistakes? Check it out. 30 seconds I will give you.
Sir, I guess there is no comma between %d and another %d.
There is no comma. So you expect that comma should be there here?
Yes, sir.
Okay, apart from that, let us go now. Let us go without the comma. Okay, let it whatever is written, let us go with that and check it. Apart from that, okay, compile and let us check whether
Sir, there should be two is equal to because it is an assignment operator. We have only given one equal to sign.
very good. That is what I was expecting from you all students. Look at line number 12. What is there? If S1 equals to S2, what is our intent? We need to compare the two values for the equality. S1's value and S2 value we need to compare for equality. So equality means we need to use two equals to symbols. Okay, now look at here. I just compiled the program. It will not give any errors, right? Because syntactically there are no problems. S1 equals to S2 with a single equals to I can write. Compiler will not give any error. It will say that, okay, you are assigning the value of S2 into S1. That's it, it says. Right now, in such cases, if you execute the program, what will happen? We will check it first. Okay, now run the program /a. Enter two sides. Now I will enter say 10 and 10. Both are the same values here. So what do you expect when I'm entering the two sides as 10 and 10? What should it display?
It's a square.
It's a square.
Output
It's a rectangle.
will be square.
Yes, output will be a square. Okay, now let me run once again. This time I will enter 10 and 20. What it should display?
Output will display rectangle.
Rectangle. Run the program. But what it is displaying here? It's a square, isn't it? Now, these types of errors are called as logical errors, right? We were expecting it to be a rectangle in this case, but it is giving square because the code what we have written, code in the sense the logic what we have applied is incorrect here. So this type of errors are called as logical errors. Now, if you look at here where the program is going wrong, one of you have as highlighted line number 12 here. So line number 12 is what? It should be S1 double equals to S2. But what we have written S1 equals to S2. So this is another type of a common mistake a student does. Whenever you want to compare a equality, you want to perform an equality. So you missed out to add two double equals to sign and you end up in writing only single equals to. Compiler will not give any error because as per the syntax, it is correct. But what happens here? Why it is giving the always it's a square? Why it is going into a true block always? Because this S1 is equals to S2. What happens here? It is an assignment operator. So S2 value will get initialized or updated with S1, right? So the operation is successful here. Assigning the value from S2 to S1, the operation is successful, means it is a true value. It assumed to be a true value, means the statement is executed. The operation is or the expression is executed successfully, means the if condition is true. The if condition is true. So for any value you take for S1 and S2, this if condition will remain as a true and it will go into the it's a square and it will print that. It will never print the other part, that is the else part, because we have made a logical mistake here. So correct that one, make it S1 double equals to S2 and then compile the program, then execute the program. This time you entered 10 and 20, it will say it's a rectangle, right? And if you go for other values, say 5,5, then what happens? It's a square. Understood, students?
Yes, sir.
Okay, fine. Now, one of you told earlier that there is comma is missing between this %d and %d. So something like this, right? Isn't it? So %d, comma %d. Okay. Now, one thing we need to remember is that in the scanf statement, the first part what we write, that is for the format specifiers, right? Within the double quote. Do not give any characters apart from the %d or a percentage of, apart from the format specifiers, don't give any characters over there. If you try to give any characters, at the execution time, the program will not behave correctly. For example, Okay, now percentage D comma percentage D I have entered here, and let us compile the program. And let me clear the screen first. Okay, compiled successfully, and then execute. Enter the two sides, say 5 and 10. It's a rectangle. Now let us check for 5 and 5. It's a rectangle. Now look at here. Look at the outputs. When I entered 5 and 5, it is taking what? Rectangle. Correct, right? So 5 and 10 both are two different sides. So definitely it should be a rectangle. It can't be a square. Next time when I entered 5 and 5, what it is showing? Rectangle. Where is the mistake? If you look into the condition, okay, condition is correct. We have put the proper condition, but where else we are going wrong here? Right? This problem is caused because of the extra comma which we have entered here. Extra comma which we have entered here. Okay, now since someone has brought into this in this class, let me tell you this comma. When we type this comma, just notice here the values how we are entering. When there are multiple values, we are entering at a single statement, like this case, right? Two values we are entering at a time, 5 and 10, 5 and 5, right? Now, between this 5 and 10, what we are entering? A space. Okay, we call it to be a delimiter, or a two numbers are separated by a space here. Or sometime even you can enter in this way also. 5, press enter button. It will not work sometime here. It should actually accept another value here. So what is causing here? The causing problem here is that the extra comma here. When there is a comma here, suppose in the scanf statement, when you enter a comma, means if you separate the format specifier with a comma, pay attention here. If you separate the format specifier with a comma, means here there are two format specifiers, both I have separated by what? A comma. Then when you execute the program, we are supposed to enter two values, right? Both the two values I need to separate it by what? Separate it by a comma. 5, comma 5. Now look at here. What output we got? It's a square, right? Earlier when you look at here, at this instant, 5 space 5 was there. It was giving a rectangle, which was a wrong output, right? Expected is the square. The difference what I made here at the run executing the program, I gave a comma, right? So for simplicity, students, for simplicity, to make it easy for the programmer, do not give any type of extra characters in the format specifier field of the scanf statement. Write it continuously. You may give a space, no worries. Okay, if there are 2 or 3, you may give a space for your understanding. But apart from a space, don't try to give any characters, because it will cause the runtime errors. Runtime errors means this type of errors, the where output will not be a wrong values. Okay, either remember in the scanf statements, when you are writing a multiple percentage symbols, percentage D or percentage of or anything, if there are more than one, okay, one thing you can do, give only one space. Remember, give only one space, or don't give anything, write it continuously. Is that understood?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Yes. Compile and then run. Check it out. This time it will work correctly. 5 and 6 rectangle. Even you can enter in this way. 5, enter 6. This time it will accept. Okay. Enter button and the space button both are accepted. Okay. Yes. Fine. Let us go to the next program. Another program. Let us try to write. Okay. Here we are going to write an area. Okay. Now, shall we look into the algorithms which we have written already? Any programs we can take it up there? Okay. This positive number and a negative number, shall we try?
Yes, sir.
Now, so in this case, our assumption is what? The number is non-zero number. or we can change our assumption to be 0 should be treated as a positive number. Both way we can check, because we are just targeting only two-way branching. A number can be a positive number or number can be a negative number only. Okay, and we can say 0 can be treated as a positive, or you don't enter a 0 number, right? Fine. So let us write the program for that. Write a C program to check the positive or negative number. Now, hash include stdio.h, then void main. Okay, then save the program first. 11 underscore positive negative dot c. Okay, so int, how many variables we require now? If I want to check a given number is a positive or a negative, how many variables are required?
One.
One. Very good. So int n, then printf, enter a number, double quote complete. Okay, then scanf %d, complete the double quote, comma, ampersand n. Okay, next. Now I want to compare whether the number is a positive number or not. How can I do? If I assume, suppose if I assume, say, assuming is treated as positive. Okay, if this is our assumption, we need to treat 0 as positive number. Then what condition I can write? If I need to write something, okay, then within the brackets I can write something, then else. So this is the else block. Okay, now tell me, first thing, condition should be what?
Greater than equal to, n is greater than equal to 0.
N is greater than or equals to 0. Why greater than or equals to 0 both? Because since our assumption we made that 0 should be considered as positive number only. So this greater than or equals to 0 is there. So if the number is greater than or equals to 0, then it will display message to be printf positive number. Okay, /n double quote complete, close the bracket and semicolon. Now, what if it is false? Then definitely it is going to print the other block, that is, it is negative number. It is negative number. Very simple, right? If the condition results in a true, it will execute the true block, that is positive number. Else, it is going to do the other part, that is in the false block. Okay, now run the program, compile and run the program. GCC space 11, no errors. Run the program. Say if I enter 6 here, positive number, correct. Now let us check. -5, negative number, that is also correct. Let us check for 0 as well, positive number, right? Understood the simple program? Any complications, any difficulties?
No, sir.
No.
Now, if our assumption is, suppose it should not take 0, then what should be done? 0.
N is greater than 0.
N is greater than 0. So we are assuming that either we are entering a number greater than 0 or a number less than 0. Okay, that should be the assumption. Now isn't it a common method or approach we require wherein we want to check for multiple conditions? So if the requirement is that we want to check it for the multiple conditions, then how can we apply such things here? Initially, we started with what? Branching statement with a simple branching, that is one-way branching. We only studied the if block, right? Then we come up with something called as a two-way branching. Why two-way branching was taken up? Because we wanted to check for both the scenarios. If the condition is true, do one thing. If the condition is false, do the other thing. Now, in this particular problem, a number can be, I no need to give this assumption always, right? So what it should be, if a number is positive number, that is if it is a greater than 0, display it as a positive number. If it is less than 0, display it as a negative number. If it is not greater than 0, and also if it is not less than 0, then definitely the number is what? A 0 number. So how many possibilities are there? How many branchings are there here? There can be more than 2 branchings. Now in this case, there were 3 branchings. One for the number greater than 0. One is for greater than 0. Second is less than 0. And the third is equals to 0. Right? So 3 possibilities are here. All these 3 possibilities cannot be handled, right? Where it cannot be handled in the if else. Then there should be another type of a mechanism wherein I can apply or wherein I can compare multiple conditions. Like you check for whether the number is greater than 0, check the number is greater than 0. If true, well and fine, display a message to be a positive number. If that is if that is false, then check again whether that number is less than 0. If that is true, then display a message to be what? A negative number. Suppose this case also, if this value is this particular condition resulting in a false value, then what it means, the number is not greater than 0, number is not less than 0. Definitely that number is equals to 0. Right? So how many branches we had here? We had more than 2 branches. So we call it to be a multi-branch statements or multi-branch control statements. Right? So we can handle those things in the control statements, and we call such type to be else if ladder. We call it to be else if ladder. Okay, now in else if ladder, how it works, let me explain you with the same program. Okay, later I will display you the flow diagram as well as the syntax. Okay, those are very simple. Okay, now, so what we said here, check for this condition, right, initially. So try to check if this number is greater than 0. In that case, what I have to display? It is a positive number, right? Now, if this is false, what has to be done? I need to, as I know, if should be followed by, if there are multiple blocks, if should be followed by what? Else statement. So I should be having an else here. But again, as I said, in the else part, what we are trying to do, we are trying to compare again. We are trying to check the condition again. So after else, write an if here again. Else, if, and then put the condition. If this condition is true, what has to be done? Display it to be a negative number, right? Now, if this condition here, the second condition in the else part, that is, we usually call it to be else if condition. We call this to be else if condition. If this condition is true, it will display a negative number. If this is also false, then ultimately we have the else part, which will check for definitely n equal to 0 value. That time we can display it to be 0 number. Display it to be a 0 number. Okay, now let us try to write the same thing again here. I'm not going to copy paste since I'm writing it for first time for the if else ladder block. Okay, now let us try to simulate, let us try to convert this understanding into a program here. Okay, now if the number n is greater than 0, if the number n is greater than 0, I need to write the true block, right? So what I'm going to display if this condition is true? I'm going to display a condition. I'm going to display a statement, printf positive number. Okay, now if not means if this condition is false, definitely I need to write an else statement. Okay, but in this else, what is my requirement? I'm going for a multi-way branching here, not only 2, I'm going for more than 2. So I can write a condition, one more condition here as a if, and then write my condition like n less than 0 in this case. Now try to understand this line, that is line number 21. So this line number 21 is called as else if condition here. It is called as a else if condition. This else if you notice, else, then there is a space and then if is there. So this type of approach is called as else if ladder. Else if ladder. We can have n number of else if statements. Depending upon the program requirement, we can write multiple else if statements. That's why we call it to be else if ladder. Okay, now come to here. So now try to understand this here. Else if n less than 0. So if this n less than 0 is true, then what I should do? I should make a statement which will print the negative number. So print negative number. Okay, /n double quote complete semicolon. Okay, now there can be possibility that the number is not a positive number, that is number is not a greater than 0 and also the number is not less than 0. Then what is the possible left out option? The left out option is the number definitely is a 0, right? In that case, I have another else already, right? Another else I have here. So else it will display print f, okay, it's a 0. It's a 0. /n then semicolon. Now look at here. Isn't it looking like a ladder? I can grow it any number of conditions depending upon the situation or the program demands. In this case, there are two conditions I'm looking for. If this is true, execute this. If this is true, execute the below statement. If this is false, where it will go? It will go to the next immediate else if condition. It will go to the next immediate else if condition. Now in this else if, what is the condition? N less than 0. Now what is the result here? If this is true, then it will execute the negative number value. If that is also false, then it will go to the last, that is else. We usually call it to be a default else, okay, or a simple else. So in this, it will execute, it's a 0 number. Okay, now let us execute and try to understand this clear. Okay, and compile the program, this 11. Now execute and initially enter say 5. Positive number. How we got the positive number? Because there is a multi-way branching. First one is what? Condition line number 17. In the line number 17, n value is 5. Is 5 greater than 0? Yes, it is true. Means it will go into its true block and execute the statement which is written in line number 19. So this will be printed. And all notice here, it has skipped all the statements. It has not executed any of the else if statement or a else statement, and it just got terminated. Okay, now second time, let us try to enter a number as a -6 here. Look at the output, negative number. How it worked? It started from the top and the line number 17, n greater than 0. So -6 greater than 0. No, it is false. False means it will skip this statement. It will skip this one and it will go to the next else if block. It will go to next else if block. In the else if block, what we have? N less than 0. Okay. Now is -6 less than 0? Yes, it is true. True means it will execute the statement which is written in line number 23. So negative number will display and the further blocks will be skipped. It will not be executed. Okay. Now let us check for the last possibility. This time I enter the number to be a 0. Okay. What I got the output? It is a 0. How it displayed the 0? It again started from the if, the line number 17. Here 0 greater than 0. Condition is false. Means this statement will be skipped. Next, else if. In else if, what is the condition? 0 less than 0. Again condition is false, so it will skip this part. Then it will go to the default, that is else statement. In the else, what we have written? Printf, it's a 0. So in this way, we could successfully able to apply the multi-way branching here by using the else if ladder. Is this particular concept understood, students? Or are there any difficulties? We can discuss on that.
No, sir.
No, sir.
Okay. Meanwhile, you enter the attendance. If there are any questions, we will take it up. So one by one, we are trying to understand all the control statements. So what we had studied, I'm just putting this content repeatedly because you need to understand all these things, right? So control statements, two types. First one is conditional or branching. Second one is
Looping.
Very good, looping. In the conditional, what we had studied so far, we had studied first one, a simple
If simple if
if statement. Second one is
else if statement. If else.
if else. And third one, which we studied now, is a
Else if ladder.
Else if ladder. Okay, now if you just try to understand how many branches this simple if does, it does one-way branching. One-way branching. One-way branching. What about this one? If else, it does two-way branching. Two-way branching. What if this one? It does multi-way
More than two.
branching. More branching. It can be more than two, basically. Here we need to understand more than two branchings. Understanding?
Yes, sir.
Okay. So that analogy, bike rider and all, that example, how can you apply now here? If else, that is else if ladder. How can you apply? Can anyone think of? See, always these simple examples are essential, right? To make it a fun learning. So initially, what was assumption for one-way branching? The rider was only fond of a coffee. Apart from coffee, doesn't drink anything, right? Else if part, we applied, okay, he can drink tea as well. So he is not there, he can drink tea also. Apart from those two, is there definitely is not going to drink anything. Now, what assumption you can make in a else if? He can drink coffee. If coffee is not there, he will ask for whether is there a tea. If there is a tea, he will drink tea. If tea is not there, then again he can ask for is a Horlicks is there or is a Bournvita is there. If anything those are there, he will drink. If nothing is there, okay, let's have fun. Okay. If coffee, drink coffee. Else, if tea, drink tea. Else, I can have one more else if here. I can check for other conditions if anything is there. If that is there, he will drink that also. Okay, if that is also not there, suppose if in the